So Anthropic's Claude Mythos just dropped, and here's why it matters, and here's why it doesn't. Anthropic just announced Claude Mythos. The numbers are staggering. An 83.1% success rate on the CyberGym vulnerability reproduction benchmark. Thousands of high-severity zero-day vulnerabilities discovered across every major operating system and web browser. A 27-year-old bug in OpenBSD. A 16-year-old flaw in FFmpeg. The automated fuzzing hit 5 million times and never caught. But here's the thing. None of that is the real story. The real story is what happens after you find all those bugs. So let me put Mythos in context, because this isn't happening in isolation. Anthropic launched us through Project Glasswing, a coalition that included organizations like AWS, Apple, Broadcom, Cisco, CrowdStrike, Google, Microsoft, NVIDIA, and Palo Alto Networks. They committed $100 million in model usage credits and $4 million in direct donations to open source security organizations. This is the industry acknowledging that AI-powered vulnerability discovery is no longer experimental, it's operational. And Mythos isn't the only system proving this out. IO found all 12 CVEs in OpenSSL's January 2026 coordinated release. Expo became the #1 ranked hacker on HackerOne in 2025, the first autonomous system to outperform every human on a major bug-bounty platform. Nicholas Carlini from Anthropic's Frontier Red Team showed that Claude was able to find a blind SQL injection in Ghost, a platform with 50,000 GitHub stars and 0 critical vulnerabilities in its history, in only 90 minutes. His assessment is that AI vulnerability research capabilities are doubling roughly every 4 months. So yeah, AI can find the bugs. That debate's over, but finding bugs has never been the hardest part of this equation. The real problem is that remediation is the bottleneck. Here's what I keep coming back to. Enterprise organizations are already sitting on vulnerability backlogs of hundreds of thousands to millions of unremediated vulnerabilities. That's not hypothetical. That's the reality for large enterprises right now. Before Mythos, before IO, before any of these AI discovery tools are even pointed at their proprietary code bases. Over 48,000 CVEs were published in 2025 alone, a 21% increase over the prior year. The Black Duck open source security report showed that 90% of audited code bases contain open source components that were more than 4 years out of date. The average application has 911 open source components, many carrying known unpatched vulnerabilities that organizations simply haven't gotten to yet. And this doesn't even account for vulnerabilities that don't have formal CVE identifiers. Now add autonomous discovery tools like Mythos scanning both open source and proprietary repositories continuously. Mythos found vulnerabilities in every major operating system and web browser. Over 99% of what it was found was unpatched at the time of the publication that they put out there. The volume of legitimate findings is about to overwhelm remediation workflows that were already underwater. This is what I've been calling the vuln-apocalypse. Not a crisis of discovery, a crisis of remediation. Finding bugs is getting exponentially easier and cheaper. Fixing them still requires human judgment, code review, testing, regression analysis, and deployment. Every fix competes with feature development, every patch cycle requires change management, and every remediation decision has to weigh security risk against business continuity and revenue targets. And security, as we know, almost always loses to speed to market. So prioritization matters, but it's not enough. Prioritization is critical, and we have better signals than ever. CISA's KEV, for example, tells you what's actively being exploited. EPSS gives you probabilistic views of what's likely to be exploited. Reachability analysis tells you whether a vulnerable component is actually reachable at the execution path. Runtime reachability validates whether the vulnerable function is invoked in production. Layer on business context, asset criticality, data sensitivity, regulatory requirements, and you can make much smarter decisions about what to fix first. But here's the honest truth. Even perfect prioritization doesn't solve the fundamental problem. You're still asking the same overloaded development teams to manually fix the findings, competing with the same feature backlogs, the same sprint pressures, the same organizational friction. Prioritization tells you what matters most. It doesn't give you the capacity to actually fix it. And that's the gap we need to close. So the real answer is AI for remediation, not just discovery. This is where I think the conversation needs to go next, and where I think the industry has a massive opportunity. So we're pouring AI into vulnerability discovery. Mythos, IO, Expo, every frontier lab and AppSec startup is racing to find more bugs than ever. More bugs faster as well. But we're not applying nearly the same energy to the other side of the equation, using AI to actually fix what we find. So my friend James Berthotti over at Lashio Tech recently published a piece that frames this really well. He's defining an emerging category he calls AI code security. And that core insight is this. AI code generation represents a third wave of development workflows, from waterfall to agile to AI-driven. And every major shift in how developers work creates an opportunity to reinvent how security is delivered. The outcomes stay the same: secure code and patching, but the workflows and underlying technologies changed completely. And here's what resonated with me about James's framing. He pointed out that the traditional shift-left model has 4 fundamental problems. Vulnerabilities are discovered over time, so you can't make everything secure by default at build time. No amount of secure developer training or stack scans can force secure coding patterns. Architectural complexity makes design review unscalable, and business logic exploits, the most common exploit type, can't even be detected by deterministic scanning. Shift-left, as the industry has implemented it, mostly just created friction. It put speed bumps in front of developers without actually producing more secure software. I've been saying this for years. The concept of secure by design and shift left are sound in theory, but the way they've been implemented in the industry has been poor at best. So what AI changes is the delivery mechanism. Instead of scanning code after a developer writes it and throwing findings over the wall, you can embed security context into the AI coding agent before it writes a single line. You can build an organizational knowledge graph, your threat models, your architecture, your security standards, your approved patterns, and you feed that to the coding agent as context. The agent generates secure code by default because it understands your organization's security posture, not because a scanner caught it after the fact. And on the remediation side, these same AI agents can tackle vulnerability backlogs autonomously. Not flagging findings, but generating contextual fixes, understanding ORM, your framework, your deployment patterns, and producing pull requests that your team reviews rather than writes from scratch. That flips the entire model. Security teams need to move from being the bottleneck to being the reviewers and architects. So as James puts it, AI security coding tools focus on maximizing the value for AI code generation for security teams rather than treating AI as a risk to be mitigated. The result is improved remediation workflows, stronger code generation, and a more effective shift-left principle that actually reduces vulnerability backlogs rather than just adding friction. So here's my bottom line. Mythos is impressive. An 83.1% benchmark score, a coalition of every major tech company, $100 million in committed funding to open source security. But we can't just celebrate the discovery side and ignore the remediation crisis. The same AI capabilities that are revolutionizing how we find vulnerabilities need to be applied with equal urgency to how we fix them. Auto remediation, contextual secure code generation, AI native threat modeling. These aren't nice to haves. They're the only way to close the gap between exponential growth in findings and our finite capacity to address them. The organizations that figure this out, that integrate AI into the SDLC not as a scanner but as a security-aware development partner, are the ones that will actually achieve what shift left and secure by design always promised but never delivered. I wrote a comprehensive breakdown on the discovery side in my article, Vulnapocalypse, AI, Open Source, and the Race to Remediate, and Resilient Cyber. I strongly recommend giving it a read as well as reading James Berthotti's piece on AI code security over at Lastio Tech for the remediation and governance side to see where that's headed. Both are linked below. As always, like, subscribe, share with your colleagues. These conversations matter, and I'll see you in the next one.